Right now, sitting 57 light years away, there is a planet that scientists have been staring at for more than 10 years, without being able to answer one basic question. What is it actually made of? Not because nobody tried. Some of the largest telescopes ever built pointed at this object for entire nights at a time and came back with almost nothing. And then, this year, one team pointed the James Webb Space Telescope at it for about 2 hours, and the mystery that had lasted a decade fell apart almost immediately. What they found wasn't just an answer. It was something stranger than the question. This is the story of the pink planet, the exotic clouds hiding inside its atmosphere, and the deeper mystery it just cracked open that nobody expected. Stay with me, because this one gets stranger the further in you go. Subscribe now if you want more stories like this, because we are just getting started. Let's go back to 2013, because that's where this begins. Astronomers, using a telescope in Hawaii, spotted something orbiting a star roughly 57 light years from Earth, in the direction of the constellation Virgo. The object was massive, several times the mass of Jupiter, orbiting its star at a distance even greater than Neptune orbits our Sun. And when they managed to capture its light directly, something about it looked strange. It had a faint reddish, almost rosy tint. Astronomers nicknamed it the Pink Planet, officially cataloged as GJ504b, and almost immediately it became one of the most talked about objects of its kind ever directly imaged. Not because it was the biggest or the closest or the brightest. It was talked about because it was so hard to explain. Here's the problem scientists ran into almost immediately. GJ504b is enormous, but it's also incredibly faint. It sits so close to its host star, from Earth's perspective, that the star's glare completely drowns out the planet's own dim light. Imagine trying to make out the details on a lit candle sitting directly in front of a floodlight from across a football field, using a phone camera. That is roughly the scale of the problem astronomers were up against. Ground-based telescopes, even some of the largest and most advanced instruments on Earth, tried repeatedly to capture a clean enough signal from this planet to figure out what its atmosphere was actually made of. Teams would book entire nights of observing time on world-class observatories, point at GJ504b, and come away with data too faint and too contaminated by starlight to draw any solid conclusions. Year after year, the same result. A planet everyone knew existed that nobody could actually read. For over a decade. That's where things stood. The pink planet had a name, an orbit, a rough mass estimate, and a nickname based on nothing more than a faint color impression. Everything else about it, the chemistry, the clouds, the weather, the actual physical nature of the object, remained a total blank. And then the James Webb Space Telescope entered the picture. In 2026, a team of researchers led by Anish Babaraj at Northwestern University pointed Webb's near-infrared spectrograph at GJ504b. This is the kind of instrument that doesn't just capture an image, it splits an object's light apart into its component wavelengths. The same way a prism splits sunlight into a rainbow, except far more precisely. Every molecule in a planet's atmosphere absorbs and emits light at very specific wavelengths, which means a detailed enough spectrum can reveal, molecule by molecule, exactly what's floating in the air of a world 57 light years away. Getting a spectrum like that from an object this faint, this close to its blinding host star, had been the exact problem ground telescopes couldn't solve for 10 years. Webb solved it in about 2 hours. The observation took a single JWST session to capture a spectrum clean enough to work with, something multiple ground-based teams using some of the biggest telescopes on the planet had failed to pull off across entire nights of dedicated observing time, over and over for more than a decade. When the team finally had that data in front of them, The initial reaction wasn't excitement about solving the mystery. It was confusion, because what came back didn't look like anything they had analyzed before. The spectrum showed an atmosphere rich in water vapor, methane, carbon dioxide, and ammonia, a mix that on its own would have been a solid, satisfying result. But when the team tried to model that chemistry using standard atmospheric models, the kind that have successfully explained dozens of other exoplanet atmospheres, the numbers didn't line up. Something in the data didn't fit the models no matter how the team adjusted the variables. There was an unexplained gap between what the models predicted and what Webb had actually measured. The answer turned out to be clouds. Not ordinary water vapor clouds like the ones drifting over your head right now. Salt clouds. For more than 15 years, scientists had theorized that certain cold, distant planetary objects might have skies laced with clouds made of condensed salt compounds, forming under conditions that don't exist anywhere on Earth. It was a real prediction, published in real physics papers sitting in the scientific literature for over a decade, waiting for an instrument sensitive enough to actually test it. Nobody had ever directly confirmed it. When the Northwestern team added salt clouds into their atmospheric models of GJ504b, the mismatch between prediction and observation disappeared. The clouds explained it. They were sitting high in the planet's atmosphere, subtly reshaping the spectrum of light coming from below, masking some of the deeper molecular signatures the way fog scatters and dims the headlights of a car you can't quite see clearly yet. This is the first time scientists have ever directly confirmed that salt clouds exist in the atmosphere of a cold, planetary-mass object anywhere in the galaxy. A 15-year-old theoretical prediction sitting untested until a 2-hour observation from a telescope orbiting 1,000,000 miles from Earth finally caught it in the act. Think about how strange that actually is. Salt, on Earth, is a mineral you sprinkle on food. It forms when specific chemical conditions bring sodium and chlorine together, typically dissolved in liquid water that eventually evaporates, leaving crystals behind. On GJ504b, something entirely different is happening. Whatever process is forming these clouds is happening in the freezing, high-pressure alien chemistry of a planetary atmosphere 57 light-years from anything resembling Earth's oceans. The same basic chemistry, salt, playing out in a setting nothing like the one that produces it here. And that's not even the strangest part of what this discovery revealed. Buried inside the same data, the team found something else. GJ504b's atmosphere appears to be unusually rich in elements heavier than hydrogen and helium, the elements astronomers collectively call metals in this context, even though many of them aren't metals in the everyday sense of the word. An atmosphere enriched with heavy elements like this is exactly the kind of signature you'd expect from an object that slowly built itself up over time by accumulating material, the way planets are believed to form. But GJ504b's mass sits in an unusual, ambiguous zone. It's massive enough that some scientists think it might not be a planet at all in the traditional sense. It might be what's called a brown dwarf, an object that started forming the way a star does, through the direct gravitational collapse of a cloud of gas, but never gathered enough mass to ignite nuclear fusion at its core and become a true star. A planet forms by slowly building up out of leftover material orbiting a young star, gradually pulling in gas and dust over millions of years. A brown dwarf forms the way a star does, all at once from the direct collapse of its own gas cloud. Two completely different origin stories, producing objects that can end up looking deceptively similar from the outside. And right now, based on everything Webb has revealed, scientists genuinely cannot say for certain which story applies to GJ504b. The heavy element enrichment in its atmosphere hints at planet-like formation. Its mass sits right at the edge of what's typically considered planetary. The team who ran this analysis has been careful and direct about it. This puzzle is not resolved. It will take further observations to pin down whether the pink planet is a planet at all or something that only looks like one. So after more than a decade of not knowing what this object was made of, the answer came back, and it opened up an even bigger unanswered question. What actually is this thing? Here's why this matters beyond one strange, faraway object with a nickname. GJ504b was, for years, effectively unreachable to serious study, not because it was rare, but because it was too faint and too close to its star's glare for the tools available at the time. There are almost certainly other objects out there in exactly the same situation. Cold, dim companions sitting close enough to bright stars that ground-based telescopes simply cannot separate their light cleanly enough to study them. What Webb just demonstrated with J504b is a method, a proof that this entire category of previously unreachable objects might now be within reach. The same instrument, the same technique, the same 2-hour observing window that finally cracked this decade-old mystery could, in principle, be pointed at the next one and the one after that. For 10 years, the pink planet sat there with a color and a name and nothing else. It took an instrument built to look at the very edge of what light can tell us, pointed at exactly the right target, to finally read what had been hiding in plain sight the entire time. Salt clouds nobody had ever confirmed. A chemical signature that raises more questions about its origin than it answers. And a reminder that even the objects we've known about the longest can still be sitting on secrets that just require the right tool, pointed the right way, for exactly the right amount of time. Scientists are already talking about applying this same approach to other faint, cold companions that have been sitting unread in catalogs for years, the same way GJ504b did until this year. Which means the pink planet might end up being remembered not just for its own strange chemistry, but for being the first proof that an entire category of hidden worlds is finally within reach. If this is the kind of story you come here for, subscribe right now and turn on notifications because we are going deeper into the strangest corners of the galaxy next time. Drop a comment with what you think GJ504b actually is, a planet or a brown dwarf. And share this with someone who needs to hear that even a decade-old mystery can crack wide open in 2 hours once you finally point the right telescope at it.